This is word problem number 5 on page 534, and if you haven't looked at number 3, you need to sort of work number 3 before you work this problem. So you can go back and refer to that video if you need to. But we have squares inscribed inside of other squares at the midpoints of each squares of the side of each square, and we start with the biggest square being a 12 by 12. So and we want to look at what's the pattern of areas and find out what's the total area of all these squares if you take them separately and getting smaller and smaller. So of course the area of the first one, area is always equal to a side squared. So for the biggest triangle it's 12 squared or 144. And then joining the midpoint, if this is 6 and this is 6, we already in the last video realized that this next square has sides of 6 root 2. So 6 root 2 squared is 36 times 2, or 72. That has an area of 72 square centimeters. And then the next triangle, or I'm sorry, the next square has side lengths we figured out in the last video of 6. So the area of that square is 6 squared, side squared. So that's 36, and you see what's happening here, and so on. This one would have side lengths of 3 root 2, this little guy in here. So as expected, this would be 9 times 2, or 18. So we see that these are getting half as big as the last one. So if I just look at the list, 144 plus 72 plus 36 plus 18, we can definitely see the numbers are getting smaller, and the common ratio, what that's going to be. So term 1 is 144, and the common ratio is 1/2. Definitely, less than 1, and this series will converge to a finite sum. So we look at it as an infinite geometric series, and it's going to be the first term over 1 minus 1/2, which is 144 over 1/2, which is 144 times 2, which is 288, and that would be in square centimeters as far as the total areas of all of those squares. And that is it.